Hi, I'm Francis O'Rourke of Team 40 from Manchester, New Hampshire. This year, my team tried something a little different. Instead of spending a week meeting and brainstorming designs for our robot, everyone on the team came together and built 6 VEX robots that could play this year's first robotics competition. At first, it seemed to be impossible, but with a lot of hard work, some ingenuity, and some teamwork, we managed to assemble a spectacular group of working robots that have proven to be indispensable in the creation of our competition robot. We call it the Mini FRC. First, there's a robot built by John and Matt. Their task was to build a robot that would pick up balls from the floor or receive balls from the human player and dump them into the side goal. After significant experimentation, the group decided to use a 4-wheel drive chassis and large wheels in order to allow them to climb the ramp and dump balls efficiently. The finished product has a tank tread pickup system, an extremely large hopper, and rollers in the front to allow fast delivery of balls into the goal. Another excellent robot is Carlo's Ball Dumper. A 4-wheel drive chassis with a hopper and an open top allow balls to be thrown into it by the human player. After trying various wheel configurations, the current 6-wheel design has been adopted because of its speed and maneuverability. Carlo's skills as a driver have served him well, earning him a place as one of the best robots on the field. Jeff, Andy, and Sam's robot has an orthogonal drive system, allowing them extra maneuverability on the playing field. However, the conveyor and shooter system is by far the most complex part of the robot. Balls reach the shooting mechanism by being pulled off the water wheel conveyor system on either side of the robot. Once the ball has reached the top, it rolls down a ramp and into the shooting mechanism. There, a pneumatic piston pushes the ball into a spinning flywheel, which is controlled by a Victor 883 speed controller. Although their drive system has had problems on the uneven floor, the shooter has been relatively successful. Their design was modified to allow for easier loading of balls into the shooting mechanism. Sean's robot, unfortunately, did not fare as well as the others. His design called for a drivetrain powered by only 2 motors, a large human-fed hopper, and flippers in the front to push balls into the goals. Despite all of his attempts to create a good ball-flipping system, a suitable design was never found. The hopper and ball release design was also too flimsy and would break quite often. In the end, the entire design was scrapped and rebuilt into a vacuum-like ball collector that has worked extremely well. One of the more spectacular robots is VJ, Brian, and Dan's robot. Originally, the design called for a spring-loaded launcher, tank treads instead of wheels, and a system to pick up balls from the floor. However, it was quickly found that this delivery system would not shoot a ball farther than 10 inches into the air. Similarly, their drivetrain was having problems turning and getting up the ramp. After a significant rebuild, the robot was able to hold a dozen balls, travel up the ramp with ease, and shoot balls up to 8 feet into the air. Finally, there is the robot that Adam and I built. Starting with a prototype crab drive chassis, we were able to quickly attach a conveyor and shooter wheel. Finding the VEX motors insufficient in terms of speed and torque, a Fisher-Price motor was used to power the spinning wheel, a development that VJ and Jeff's robots would eventually use as well. Another problem arose when it was found that the design called for more motors than there were ports on the VEX controller. In order to overcome this, it was decided that we would use 2 VEX controllers that were linked together. One of the controllers controls the shooting wheel, ball incrementer, and drivetrain, while the other controls the servos used in the crab drive. Despite its mild success in competition, the designs for the shooting wheel, ball incrementing system, and multi-directional drive have all been used on this year's competition robot. The use of VEX robots for prototyping has done more than just help us with the design of our robot. It has brought us together as a team. Groups have worked together to build better robots, and new ideas have been shared amongst the team members. More importantly, though, it has taught our team that working together on a common goal can produce stellar results.